All right, so we're going to take a look here at quadratics. This is the beginning of chapter 2. So the first thing about quadratics is well, we're going to be concentrating on what does it look like, and then what do the different things? How do we find the different elements? Then we will go into later what does this mean? How does if we had a scenario, what would each of these things represent, and which ones make sense? Things like that. So the first thing we need to understand is how to tell the direction of the graph. And so right here for the direction, what you want to do is you want to look at, so what we do, so you're going to look at the x squared term. Okay, that's what we want to start off with. We want to start with the x squared term. So in that, there we go. So there's our x squared term in this one. Here's our x squared term in that one. Okay, so this is the direction. And so what we're going to say is that this is positive. And it's what I would call a happy parabola, which means that it opens upwards like this. And so what I am looking for it to hear is concave up. Okay, concave up is what that means. On this one down here, we have negative 2x. Now this then negative means it's a sad parabola, like so. And if this one's concave up, this would be concave down. And that's what we're talking about with direction. So whether it's concave up or concave down. So whether it opens up or opens down is the idea. And that concave is this is a phrase that we use. It's a calculus phrase, and since this is pre-calculus, we're going to use calculus terms. So concave up or concave down. All right, vertex. Now to find the vertex, so step one, we want to make sure the terms are in order. Okay, that's going to be step one. Make sure the terms are in order. Step two, we're going to say x equals negative b over 2a. And then step three, whatever we get there, we're going to plug whatever the answer is, we're going to plug that answer into the function. So again, 3 special steps. That's all that you need. So the first one, we got this. And what I mean by order is this order means decreasing exponent is what that means. So do the exponents decrease? X squared, x, no exponents. Yes, they decrease. So great. Now, what's going to happen is we're going to have y equals ax squared plus bx plus c. So a is the x squared term, b is the x term, and c is what we call the constant. So in this case, we'd say, okay, cool. So x equals negative b, so negative 2 over 2a. A is, if there's nothing there, it's 1. Negative 2 is positive 2. Divided up positive 2, so we get 1. So x equals 1. That's our x-coordinate for our vertex. We know it's concave up, but we're going to have an x-coordinate of 1 right here. And so then what we're going to do is like, okay, cool. And then we're going to do y equals, and now we're going to put in that 1 everywhere. So 1 squared minus 2 times 1 minus 15. So then we're going to have y equals 1 minus 2 minus 15, which comes out to negative 16. So our vertex is 1 comma negative 16. That'd be our vertex. That first is for example 1. All right, so let's look at example 2. All right, so example 2. Are the exponents in order? No, because it goes 1, 2, 0. So we have to put them in order. So that means we're going to write it as y equals negative 2x squared plus 20x minus 48. Then we're going to use our x equals negative b, which is negative 20, over 2 times a, which is negative 2. So I have negative 20 divided by negative 4, which is positive 5. So I have my x term. Now I'm going to take that, and I'm going to substitute that in, plug that into the function. So y equals negative 2 times 5 squared plus 20 times 5 minus 48. 5 squared is 25, so that's negative 2 times 25. 5 times 20 is 100 minus 48. So now now that is negative 50. These we can actually combine. 100 take away 48 is positive 52. So I have negative 50 plus 52, I get y equals 2. So that means my vertex is 5, comma 2. That's how that goes. So just follow those 3 simple steps to get the vertex. Now you've done this before back in Algebra 2, so it's just a little bit of a memory thing. The y-intercept is probably the easiest part of the whole thing. That's going to be 0, comma c, 100% of the time, if we have it like this. So for example 1, it's going to be our y-intercept. It's going to be 0, comma, go back up here. Oops. So 0, c is the last one. It's constant, negative 15. So 0, comma, negative 15. All right. Then for example 2, or we'd say our y-intercept. Then we look here, and remember it's 0, comma c. C is the last number, so 0, comma, negative 48. Now, not always will it be a negative value. Now, these ones just happen to be that case, so don't think that c is always negative. And if you remember doing this before, then you're okay. Okay, x-intercepts we have can be tricky. There are multiple ways to figure out your x-intercepts. Basically, we're going to solve, 0 equals ax squared plus bx plus c. And you have 3 main options that people tend to look at. One of them, I'm just going to tell you, most people don't use it because it's a headache. It's the one with the most work, and that is the what we call completing the square and then solving the equation. That one takes the most work. Okay, we're not going to worry about that. So here's our options. We have 2 main options. So option 1. Now option 1, I'm going to call option 1 because this one, if you can do, you should try first. Factor. So if you're good at factoring, I would say that's option 1. Option 2 is if factoring doesn't work, then we use a quadratic formula. Okay? So either one of those will be fine. Personally, I prefer to factor if I can, quadratic formula if you can't. So what we would do then is we'd start off, okay, purple. All right, so remember example 1 was y equals x squared minus 2x minus 15. And so if we factor that, we're going to set that equal to 0. So we're going to be x minus 5 and x plus 3. And so then we set each one equal to 0. X minus 5 equals 0, so x equals 5. X plus 3 equals 0, so x equals negative 3. And so that's how that would go. Now, you probably learned a different, longer way of factoring, talking to your Algebra 2 teachers, and that's okay. And so if it takes you longer to do that, then it takes you longer to do that. Okay, now, let's take a look at the other one. So we're going to say 0 equals negative 2x squared plus 20x minus 48. Okay, and so then we're use the quadratic formula. X equals negative b, so that's negative 20, plus or minus the square root of b squared, which is 20 squared, minus 4 times a times c, like so, all over 2 times a. Don't forget that. A lot of people forget that bottom part. All right, so then we have negative 20. This equals negative 20. Plus or minus 20 squared is 400. See, 4 times 2 is 8. 8 times 48 is 196. And negative times negative is positive times the negative is, no, 192. Never mind, 192, right? No, 300. Yeah. Okay. 8 times 8 is 64. Okay, to 6. 4 times 8 is 32 plus 386. There we go. No, 396. All over 2 times negative 2. There we are. Okay. Real quick, let's just check that. Big numbers are hard. 4 times 2 times 48. 384. 384. Okay, 384. There we go. All right, cool. So 384. Fantastic. Okay. So that means negative 20 plus or minus the square root of 16 all over negative 4, which means negative 20 plus 4 over negative 4, and negative 20 minus 4 over negative 4. That makes negative 16 divided by negative 4, which is positive 4. This makes negative 24 divided by negative 4, which makes positive 6. And so we get x equals 4 and x equals 6. So both of these now, what we're going to do then is we're going to call it, this is our x-intercepts are 4 comma 0 and 6 comma 0. Over here, our x-intercepts are 5 comma 0 and negative 3 comma 0. And then we could take all those things and put them together into one graph. And so we have 5 0, negative 3 0. We had our y-intercept was negative 15. We had a vertex at negative 1 comma negative 16. And we know it's going to be concave up, so the graph is going to come through like that, except for prettier. But again, you don't need to be Da Vinci. You can get away with just being Picasso. All right, over here we have 4 and 6, and then we had negative 48, and then we had 2 comma 5 comma 2. And so we had these points, and it was concave down. So for like that. Okay, and again, doesn't need to be perfect, just give the idea. So, any questions?